Hello everyone, I'm Vivek from K4 Metrics and we support SmartUQ in India. The purpose of SmartUQ is to take the data, whether data from a CAE solver or a historic data or a test data, etc., create a surrogate model and use this surrogate model for subsequent studies. In the previous video, we saw how we can sample the design space, what a DOE is, some of the DOE options in SmartUQ. And I also created a sliced DOE, that is 25 slices, each containing 15 grams. So there are three things that needs to be done outside of SmartUQ if you're using a CAE solver. And these are creating input for the CAE solver, running the solver, extracting the data from the solver, and converting the data into the format that SmartUQ uses. So for solvers like ANSYS, Adams, COMSOL, etc., SmartUQ has automated the process. And this example shows the integration between ANSYS and SmartUQ. So you specify the workbench location and the project file. And when you click on retrieve info, ANSYS will send the details about the input and output parameters to SmartUQ. You take the input parameter names, you specify the lower and upper bound, like how we did in the first video, and you create the DOE. So once you have the DOE with you, you go for prediction, you click on submit, and SmartUQ will send the data, the DOE or the input parameters to ANSYS to conduct the simulation. Once the simulation is done, ANSYS will send back the result data to SmartUQ. There is a webinar which explains in detail about the integration of ANSYS and SmartUQ. So I will leave the link in the description. But what if you're using a solver that is not integrated by SmartUQ? In our case, we are using SU2 and we will see how we can accomplish these three outside of SmartUQ steps. First off, we'll be using a SU2 tutorial and we'll be taking this Naka airfoil tutorial as this suits our needs. And for solving any problem in SU2, you require a mesh and a configuration file. So here is the mesh file. So this left image shows the complete mesh file till the far field, and the right image shows the zoomed in view, and you can also see the airfoil profile here. So this is one of the inputs. The second is the configuration file. So configuration file is nothing but a text file that contains options to solve a specific problem in SU2. So the contents of safety file is something like it will contain the turbulence model that you are solving, the input parameters and their values, the boundary conditions, and here you specify the mesh file and also what format SU2 you want SU2 to write the output in. So you can see that it is also writing in CSV format. Note that in our problem, the only change in configuration file that we need to make is the values of the input parameters. So if we do this manually, we would have to edit the configuration file for each combination of input parameters. Since we want to do this automatically, so this would be the first thing that we need to automate. The second thing would be we need to automate running the solver. There are a number of ways you can manage CAE data, one of which is creating a separate folder for each solution, and this is what we'll be using, and you will be seeing something like this in your working folder. The third thing, we need to extract the data from SU2 and convert it in the format that SmartUQ uses. You can use any automation tools for this. Since we are using Linux, we'll be going with shell scripts and Python programs. Note that this will not be covered in these videos, but SmartUQ do have a Python API. So to recap, SmartUQ writes the DOE out as a CSV file, and this is what it looks like. We have chosen to create a folder for each solve, so we need to create these folders automatically. We already have a mesh file that we can use as is. So every sol uses the same mesh file. We need to edit the configuration file for each sol. We have to change the input parameters to whatever specific the DOE slice requires. So the left image is the input parameters that we got from the configuration file from the SE2 tutorial. And here right side is the input parameters that we'll be changing it with, that we got from the DOE, and along with the uh, input values. We then need to run SU2 within the folder designated for this slice. And finally, we need to extract the results into a form SUQ wants. The programs that we have used are, one is script run DOE sh. So this is the program that does pretty much all the work. It reads the CSV file with the DOE specifications, creates a folder for each slice, places the CFG and mesh files in the folder, edit the CFG file as per the DOE specification, run SU2, and save the output in a CSV file. This CSV file will be called a Y matrix, as the terminology that is used in SmartUQ is Y matrix for the output table and X matrix for the input table. And in this table, the number of rows depicts the number of simulation runs, and the column depicts the input parameters. The other program that we are using is master run su2.sh. This is fairly trivial. It runs su2 with the cfg file on the command line. So if you are doing this manually, so how it would look like is that if you'll be going inside the folder where the cfg file resides, you specify the path to the SU2 executable, and you specify the CFG file and press enter, and SU2 starts solving the simulation. So now let's look at how the script run doe.sh works. This is what our working folder looks like when we have exported the DOE from SmartUQ. So all it contains is the CSV file and the grid file and the configuration file that we downloaded from the SU2 tutorial. Some modifications have been made to the configuration file such that we can search and replace certain parameters. So if you see the top image, it shows the image from the SU2 tutorial configuration file, where it shows the input parameters and the values that is used. And at the bottom, it is shown the modification that we have made. We have made these modifications such that we'll be able to search these strings and edit with the specific DOE values that comes from the CSV file. Now, when we run the shell script, that is run doe.sh, and it create the simulation is run. So this is what our working folder will change once the script has completed. Note that we have chosen to write our program so that we run the script once for each DOE slice. How does the script go from the top image to the bottom image after running the script? So let's understand this by walking over the shell script here. Remember that the variables that you are seeing here in green are programming variables, that is the values that we create for our program. The names should be self-explanatory, but do reach out to us if you have any questions. So line 16 here is the loop that reads each entry in the CSV file. Remember that for our DOE, we selected 15 runs per slice. And line 28 and line 34 show how we create a folder for each run in the slice. The folder name reflects the slice number and the DOE number. Coming to line 37 and 39, these two make a copy of the configuration file so that we can edit it for the particular sol. And line 38 and 40 also copy the shell file we used to run the SU2. Next, coming down from line 43 to line 47, this uses the stream editor SED to search for and replace the text strings. As I shown in the earlier image, we'll be replacing those input parameter text strings with the values from the CSV file. Coming down line 50 and 51, this file will be moved this to the move the edited file to the folder for doing the solve, and line 54 and 55 will run the SE2 within the folder. Finally, our objective in SmartUQ is to review the effects of the input data on the coefficient of drag and lift. So SU2 writes a history file. This was set in the configuration file. We will not be covering the details here. So lines from 60 to 75, the values are extracted from the history file using the Unix utility AWK and append the data to the Y matrix as shown in line 77. And once you have the file with you, so this is how the Y matrix looks like. It contains the slice number, the DOI number, the iteration at which the solution got converged. The input parameters are added in the output as well, and these two are the coefficient of drag and lift values. So this is after the first solve, and the same pattern will be repeated for the subsequent solves as well. So this completes part 2 of this series. So in part 3, I'll be showing how you can load this Y matrix back to SmartUQ, how to create the surrogate model, how to check its accuracy, and how to improve the accuracy as per your requirement. So if you have any questions on what I have shown in this video, drop a comment down, or you can email at support@kformetrics.com.